we're going to look at solving absolute value equations. And so that's what I have here. I have an absolute value, and it's an equation. There's an equal sign. So we've got to find the absolute value of x equals 4. Let's go back to our number line. And you'll remember that an absolute value is a distance. So here we know the distance. The distance is 4. So the question becomes, what number, or maybe what numbers, if there's more than one, would be 4 units away from 0? So let's see, I have two choices. I could go this way. Here's a number that is 4 units away from 0, or I could go in the negative direction. Here's another number that's 4 units away from 0. So we could say there's two answers here, x equals 4 or x equals minus 4, because, and we can always check our answers with an equation, whoops, if I put 4 in for x, the absolute value of 4, of course, is 4, and if I put negative 4 in for x, the absolute value of negative 4 is 4. So when we're solving absolute value equations, typically there'll be two answers. One will be if we go in the positive direction away from 0, so we assume that what's in the absolute value is positive, or the other one will be if we go in the negative direction, so we assume that what's in the absolute value is going to be negative. Another way we could look at doing this is we could draw a graph of the function. So here's a graph of y equals the absolute value of x. So the absolute value of x graph would look like this, and we want to know where does it equal 4. Well, there's where the line 4 is. Oops. So here's y equals 4. And so we can see there's two solutions here. The absolute value of x equals 4 right here, when x is minus 4, or the absolute value of x also equals 4 right here, when x equals positive 4. So the absolute value of x equals 4 would have two solutions, 4 and negative 4. And we can see that on a number line, and we can see that on a graph. But often we want to be able to do this algebraically. So let's look at some examples where we're solving algebraically. So here's the equation. The absolute value of x minus 2 equals 4. So we know there's going to be two possible scenarios here. Let's look at the first case, scenario 1. Let's assume that what's in the absolute value signs, that's this stuff here, x minus 2, let's assume that that's greater than or equal to 0. So if we assume that that's greater than or equal to 0, then to isolate x, when we add 2 to both sides, we're going to make an assumption here that x is greater than or equal to 2. Because if x is greater than or equal to 2, if it's a number like 3, 4, 5, or 2.3 even, that number minus 2 will be positive. And if this is positive, then we don't need those absolute value signs. So the equation's just going to become x minus 2 equals 4. So x minus 2 equals 4. We know we don't need the absolute value signs anymore because we've said x is greater than or equal to 2. So that gives us this very easy equation to solve. We're just going to add 2 to both sides, and we get x equals 6. So if x is equal to 6, when we substitute this back in, let's check. Six minus 2 is 4, and the absolute value of 4 is 4. So we know that x equals 6 is correct. The other thing that we needed to confirm is, does this fit with our assumption? So we assumed that x was greater than or equal to 2. We came out with an answer of x equals 6, and 6 was greater than or equal to 2. So we found the number to the right of 0 such that 6 minus 2, the absolute value of that, is a distance of 4 away from 0. The other situation is to the left of 0. So now what we'll do is we'll assume that what's in here is less than 0. So we're going to assume that x minus 2 is a negative number now, which means when we add 2 to both sides, we get x is less than 2. So if we make x something less than 2, then what's in the absolute value is going to be negative. Now what we need to do to our equation, x minus 2, is we need to multiply it by negative 1. Because remember, that's how we make it positive. When you remember, think back to the graphs when we were graphing function, these values down here that had the negative y values, we had to multiply them by minus 1 to make them positive. We multiplied those times by negative 1. So we're going to, now that we know that this is going to be negative, we're going to take x minus 2 and multiply it by negative 1 and solve our equation. So negative 1 times x is negative x. Negative 1 times negative 2 is positive 2. And finally, we can minus 2 from both sides here, trying to isolate x. And then we can divide by negative 1 to get x equals minus 2. So x equals minus 2, and does that fit with our restrictions on x? Yes, x had to be less than 2. This is definitely less than 2. So let's double check. The absolute value of negative 2 in for x, minus 2. Negative 2 minus 2 is negative 4. And the absolute value of negative 4 is positive 4. So left side equals right side. So just reviewing again, when we have an absolute value equation, we're going to do two different scenarios. First, we're going to assume that x minus 2 is greater than or equal to 0. So that's what was in the absolute value signs. And then isolate x there so that you know that x is greater than or equal to 2. Then solve your equation without the absolute value signs because you're assuming this is positive. In the second case, take what's in the absolute value and set it less than 0. So in other words, x is now needs to be less than 2. This time, because this is negative, we need to multiply the absolute value part by negative 1 because that's going to make it positive. And when we solve that equation, we get our second answer. So the two solutions to this question are x equals minus 2 or x equals 6. This would be our final solution to this question. Two solutions. Let's look at another example. How about the absolute value of 2x plus 1 needs to equal 3? So let's assume, in case 1 here, the first situation, let's assume that 2x plus 1 is greater than or equal to 0. So let's make what's in here positive. Isolating x, so minus 1 from both sides, and dividing by 2. This means that x needs to be greater than or equal to negative 1/2. So we're gonna assume that. If we know that x is greater than or equal to negative 1/2, then we don't need to write the absolute values because it's positive. And now we can solve for x. Minus 1 from both sides, and finally divide by 2, and we get x equals 1. Now going back and checking, did that fit with our assumption? X needed to be greater than or equal to negative 1/2. This is definitely greater than or equal to 1/2. So this is satisfying this condition. We can check in the absolute value here too. So 2 times 1 is 2. 2 plus 1 is 3. And the absolute value of 3 is 3. So that answer is good. In the second situation, so case 2, let's now assume, so we've gone to the right of 0 on our number line. Now we're going to go to the left. We're going to assume that this is less than 0, which means 2x is less than minus 1, which means that x is less than negative 1/2. So if we assume that x is less than negative 1/2, then our question was 2x plus 1 equals 3, but because this is negative, we need to multiply everything by negative 1 to make it positive. So now we have our equation that we can solve. That's negative 2x minus 1 equals 3. Add 1 to both sides. Divide by negative 2. We get x equals negative 2. Negative 2 is a number that is less than negative 1/2. So that's good. And checking it in our absolute value, 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. The absolute value of negative 3 is positive 3. So we're going to have two solutions here, x equals minus 2 and x equals 1. How about the absolute value of 3x minus 2 equals 3 plus 4x? Well, let's look at our first situation here. Case 1, let's assume what's in here is positive. So then to figure out what our restrictions on x need to be, we'll add 2 to both sides. And then dividing by 3, we're talking about x values that are greater than or equal to 2/3. So once we solve this, we got to make sure x is greater than or equal to 2/3. So let's do this now. So since we're assuming this is positive, we're not going to need the absolute value signs. 3x minus 2 equals 3 plus 4x. So we will, let's minus 4x from both sides to get rid of that. So that's negative x minus 2 equals 3. Now we'll add 2 to both sides. Negative x equals 5. Divide by negative 1. And we get x equals negative 5. But whoop, we got a problem here. Because in our assumption here, we're assuming that x has to be greater than or equal to 2/3. This is not bigger than 2/3. It's a negative number. So since this doesn't satisfy our restriction, we have to reject this answer. And answers that, when we do the algebra, need to be rejected, they're called extraneous roots. That's just some vocab. So it's a root, but it needs to be rejected. It's an extraneous root. So far we don't have any solutions to this thing. Let's look at a second case here. So now we're going to assume that what was in the absolute value sign, 3x minus 2, is less than 0. So we will add 2 to both sides of our inequality and divide by 3. So now we're talking about x values that are less than 2/3. So since these are negative numbers, we need to multiply them by minus 1 to make them positive. And multiplying the negative in here is negative 3x plus 2 equals 3 plus 4x. Minus 4x from both sides is negative 7x, and minus 2 from both sides would equal 1. And now divide by negative 7, and we get x equals negative 1/7. So is negative 1/7 less than 2/3? Yes, it is. Negative number is less than 2/3. So this solution is good. X equals negative 1/7, and that will be our only solution to this absolute value equation. Sometimes it's even possible to come up with an example that has no solutions. So if you consider this one right here, usually when we have an equation, we want to isolate the absolute value part. So the first thing I'm going to do is I'm just going to minus 5 from both sides before we even get started here, so that I have the absolute value part isolated. And then it gets, so it looks like this. Well, right at this stage right here, you should realize this is never going to work, because the absolute value of x minus 2, the absolute value says make it positive. Well, how can something, when you make positive, how could it ever equal negative 4? So this would be a situation where there simply is no solution. So the absolute value of x plus something, or any absolute value of something, can never equal a negative number. So there would be an example of no solutions. We can also solve absolute value equations that have quadratics in them. So here, same way, case 1, let's assume that x squared minus 2x is greater than 0. Now this gets a bit trickier with the the parabola with an x squared in here because it's not just so simple isolating for x. So what we would need to do here is there's a common factor of x here. We can take that out. And so what we're really asking is, where is x times x minus 2 greater than 0? Well, we could think of our roots. So if you think of x times x minus 2, where does it equal 0? Well, we'll know it equals 0 at 0, and we know it equals 0 at 2. X is 0 or x is 2. So now we can analyze what happens to our function here when we try points that are less than 0, like there's region 1, here's region 2, here's region 3. So if we, in region 1, if we try negative 3, pick a number less than 0, say negative 3, a negative, and this would also be a negative, negative 3 minus 2 is negative 5. So a negative times a negative, remember this is our positive, this would be a positive region. And when we try a number between 0 and 2, like 1, this is positive, 1 minus 2 is negative, a positive times a negative is a negative. So region 2 produces negative numbers. And when we try something more than 2, like 5, positive, 5 minus 2, positive, positive times a positive is a positive. So we want to assume that this is greater than 0. That means that x has to be less than or equal to 0. Well, let's do equal to here. So s has to be less than or equal to 0 because this is our positive region. And our other positive region is x greater than or equal to 2. So we can solve this as long as x is less than or equal to 0 or x is greater than or equal to 2. So since this is positive, we don't need the absolute value signs. And we can set this equal to 0. Whoops. And now I can factor this one. No, I can't factor this one. Two numbers that multiply to 6 and add to minus 2 aren't going to work. So there's always the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this would be 2 plus or minus the square root of b squared, 4, minus 4 times a times c all over 2a. So carrying on with the quadratic formula, I get 2 plus or minus, now the square root of 28, I can write that as the square root of 4 times 7. So that's 2 root 7, all divided by 2. So this becomes 1 plus or minus root 7, because 2 divided by 2 is 1, 2 divided by 2 is 1, so 1 plus or minus root 7. So let's see, I can take any answers as long as they're less than or equal to 0 or greater than or equal to 2. So let me just check that these would work. Let's go 1 plus the square root of 7. So one answer is 3.65. So that's fine. That's greater than or equal to 2, 3.65. And the other one would be 1 minus the square root of 7, which is negative 1.65. So both of those answers are good because this one was more than 2 and one was less than 0. So both of these solutions would be correct. Now, going back to case 2, we're going to assume that x squared minus 2x is less than 0. So we've already kind of done the work here because we can see where it's negative. Here's where x squared minus 2x is going to be less than 0. So our x values need to be between 0 and 2. Now, again, since this is negative, we're going to take our absolute value and multiply it by negative 1. So this becomes negative x squared plus 2x equals 6. Bring the 6 over, And I don't like starting with a negative x squared, so I'm going to multiply everything here by negative 1. Whoops, lost the x there. There we go. And again, this is not a pretty to work with because it doesn't factor very well. So x equals negative b, which will be 2 plus or minus the square root of b squared. Whoops. That's negative 2 squared minus 4 times a times c all over 2a. And I can see right now we're going to have a problem right here because negative 2 squared is 4 minus 24, and 4 minus 24 is negative 20, and we cannot take the square root of a negative number. So we're done here. We're not going to be able to find any solutions in that situation. So the only solutions we found were in case 1 here. X will equal 1 plus or minus the square root of 7. So that's how we solve absolute value equations. Look at case 1 by assuming what's in the absolute value is positive, and then solve the equation as it's written without the absolute value signs, making sure that you check with your restrictions. And in the second case, assume what's in the absolute value signs is negative, is less than 0, but then you got to make sure that you take the expression in the absolute value and multiply it by minus 1 because you're needing to make that positive. This will take a bit of practice. You practice a bunch of questions and then you'll get comfortable working with case 1 and case 2 and following the procedures, because some of these ones, especially the quadratics, there's a lot of steps here to solve the absolute value equations.